Hello and welcome to this buildingSMART Room session as a part of the buildingSMART International Standards Summit, Rome 2023. Thank you for joining. For those of you joining us here in person and those online. My name is Jeffrey Ouellette and I will be your moderator today. Today's session is entitled 4D and 5D IFC4 for Cost and Time Management, Project Management Command Center using OpenBIM CDE. We're joined by Aleksandar and Veljko, or Mileta. Mileta, okay. This session is scheduled to last 90 minutes. Hopefully there'll be some time for Q&A. The session is being recorded and will be made available in the replay section of the event on the Hopin platform as soon as possible. Before I hand it over to our speakers, though, I would like to remind you that this is a hybrid event. For the online attendees, their microphones will remain muted for the duration of the session. If those of you online have a question, just please put it in the chat box in the control panel and I'll pass it along to the presenters. For those of you in the room, please try to keep the background noise to a minimum. Raise your hand if you wish to make a comment or ask a question. I do have room mics here, and so I will bring that to you, and that is to give the people online the opportunity to hear your comments or questions. Yes, the window is open. We're having comfort issues. You can try to close it a little bit, but we'll see how it goes heat-wise in here throughout the thing. What do I got here? I got one more slide this will show. Those are our speakers. So I would also like to bring your attention that buildingSMART is committed to ensuring that the participation in the development of standards is unrestricted and the process for their adoption is transparent, and the standards that are developed do not favor any particular provider, are open, non-binding, and accessible to all. Please take note of our antitrust code of conduct that can be found on the buildingsmart.com, buildingsmart.org website. So let me get this set up now. That.
Okay, hello everyone. My name is Aleksandar Ilić. I'm a BIM manager and product specialist in Veljko company. And today, me and my colleague Mileta Pejović. Sorry, yeah, thanks. Me and my colleague here, Mileta Pejović, we will try to give you, our perspective on BIM and to give you more focus on project management command center using OpenBIM CDE and IFC4 for cost and time management. At the beginning, just a few words about our company. We are a software vendor and consulting company with a range of BIM products. We are a multinational member of buildingSMART, and we are dedicated to integrated BIM project management, BIM education, and BIM implementation. We have our clients all around the world from different roles, from different roles in the construction industry in general. And I could say that, but mainly like 80% of our clients are large investors, project managers, and contractors. So I would say that we are mostly focused on that side and on the designers side. First, whenever we start about construction industry in general, we have to start with the challenges and problems, and these are just some of the things that you have probably heard many times. What are the challenges in the industry in general? And those are the poor working planning, location time conflicts of tasks and activities, time and material waste. In general, construction projects are actually complex projects because more or less on every new project you're building a prototype, and so all of these challenges are understandable. And in order to overcome such challenges is a big task in general. What we tend to do these days, or we try to go with the accommodate environment approach, where we want to have a platform where all the participants of the projects could work together. But what is a challenge in this approach is that it becomes often a common document environment. What this means? This means that digitization, to digitize the process for some people means just to change the format from hard copy to digital copy of the document and not change the workflow and not change in general, I would say, data, how the data actually works. What we mean by this is what I quote, digitize process by simply converting your documents from hard copy to digital copy and then upload it to CD, share it with other participants. But of course, yeah, some documentation could be managed this way, but majority of the project data had to be set up in a different way. It had to be organized and managed in a such way that you can see a portion of data that is relevant for you as a participant at the right moment. And of course, that stakeholders could see a big picture of the project and not just to see documents which you have to open and read to understand, and then you have to open, a large amount of data to read it to understand what the big picture is. You need to have option to actually inspect the data and sort it in a proper way. Well-established CD must be populated with, of course, relevant and reliable information that could be managed properly, which means that information could be sorted, filtered, and verified from different participants. And of course, it has to be delivered on time. For example, if we have information about productivity of construction site this month from the previous month, then we can react and mitigate risks in the future. But if we have it in 2 months, that information is probably useless at that moment because you just cannot react in a proper time for a proper situation. So in general, this means that CD must include a BIM model versioning, document management system, regularly updated reports with relevant traceable data. What I mean by traceable means that you can verify how the data was created. And that could be verified by other participants. And this is what will be a focus of our today's presentation. Of course, collaboration workflows and clearly defined access rights in order to deliver right information in the right moment for the right stakeholder. What we see as a major challenge in achieving these goals in industry today is a fragmentation of project management workflows. So we have siloed domains, which means we have limited interconnection of the data in different stages of the project. So this leads in the first place to inefficiency because everybody is working its part of the project management, I would say, from scratch, because they don't have reliable information from the previous phase. And even if they have it, they could not read it in the proper way. It's in a wrong format. It's not machine readable. It's not standardized. And therefore, we are basically losing a lot of time on this rework on every new phase. And this is typically a characteristic of non-BIM-centric, what we call it, non-BIM-centric project management. For solution for this would be a BIM-centric project management, where project management process is integrated in terms of workflows and in terms of information source, which means that every stakeholder speaks the same language of the sort, that data is transparent, data is traceable, and the participants could rely upon information delivered by other teams. So, of course, prerequisite for this is standardization of data exchange, and this is where buildingSMART has a key role in making such concepts a reality. So the goal is to improve efficiency, to streamline processes, and to improve accuracy and time needed for data delivery, and of course to improve overall management engagement. So we can say that such an integrated BIM project management platform becomes reliable source of project information based on which accurate reports are then produced and regularly updated. And such reports are then approved by managers and give them just-in-time information and a sort of reliable base for their effective decision-making. So in short, BIM model in this case becomes a single source of truth for all participants, and it encompasses all relevant information in one place, and change in one place is reflected on all other places, so every participant has the same picture of the project. Of course, in order to ensure such role of BIM model on the project, we have to make sure that all the data is reliable and verifiable. We have to ensure that data is machine readable and standardized, and we need to have an automated quality control workflows to ensure that large amount of information that is needed for such an integrated workflow could be processed on time and managed properly. And of course, besides the data management and data control, which we mentioned in the previous slides, we also have to focus on the data creation process, or feeding the data of our single source of truth. So if we truly, if we want to fully digitalize and streamline processes of data management, we have to create efficient processes of creating the data, of inputting the proper data in the source, because if we don't do that, I mean, the people are not feeding the model with the wrong data, or with the false data because they want, but because they just don't have enough resources to do it in traditional way properly. So we need to automate those processes to just release these resources and focus on what is important on the data quality, and to remove those, I would say, manual repetitive tasks that project managers have to deal with on day-to-day basis. And this is just a general ecosystem of our software solution. So where we try to implement these principles. So in the center is we have an integrated expert BIM platform, which basically encompasses all different modules and functionalities that are used throughout the project life cycle. So from the beginning to the operations and maintenance. And besides that major expert source of analytical tool, we have also a range of cloud-based solutions, which are mainly focused on exchanging the data and collaboration between other participants. That means that the data can unobstructedly flow from the expert tool to other stakeholders, and vice versa, that, let's say, for example, information from construction site can come back to the federated BIM model, and that you have this two-way collaboration. What is also important is what we call a knowledge base concept. That means that you're not just exchanging the project information, but also the knowledge data. That means that you can exchange the templates, you can exchange the classification systems, you can exchange the knowledge with other teams, and improve the efficiency with every new project, with every lessons learned. And of course, the last part is the integration with the third-party systems and databases, namely, databases and ERP systems that could be incredibly valuable resource, which were not generally developed for construction industry in general, but could prove to be very important in process of improving the efficiency of construction management overall. So in our case, we have one platform that is used throughout the whole project life cycle. So by the different stakeholders in the different phases of the project for the different analysis. And the main advantage is that you can verify and you can reuse the information from the previous phase as the basis for your next phase. So let's say you're sure that after model data verification, clash detection was done in the platform before, you can rely upon the high quality data when you start with the quantity takeoff, scheduling, cost classification, and so on. Once you integrate the 5D and cost classification, you can rely upon, the planner could rely upon the information about the resources, about the cost, materials, and everything else. And of course, one of the important parts is that all of these workflows are automated so that you can focus on creative tasks and improving quality of the data that are going to the model, and to forget about the manual repetitive tasks that are just wasting the resources. And this is general workflow, which could be described as a chain of processes that are just a sort of executed in a chronological order, more or less, throughout the project life cycle. But besides that general workflow, we also have in parallel two main processes that are present all the time. And one is, of course, maintaining and updating federated central BIM model. And another one is reporting and analytics. So in every phase of the project, from every stakeholder, in every moment of the project, you need to report that data properly, you need to report it in a proper way, in the right time, just in time, and you need to just deliver it to the specific people that need to see that data, to understand the data, and to make decision. And today we will focus mostly on this process of reporting and how it works in our ecosystems, in our ecosystem in general. So we will just go through the different processes in project management and explore and explain process itself, the level of automation achieved in these processes, but we will focus on reporting on the data that is created and that could be successfully managed as a result of these workflows. So now we will switch to my colleague, and he will just cover the 3D workflows first, and then we will go with the 4D and 5D later. Yes.
Pop that one on right.
Ah, yeah, that's one.
Yeah, should be able to. You should be okay.
Hopefully you can hear me. So I'm going to continue with the part which is maybe more interesting for the common, let's say, participants on the project, where we will present some of the workflows and how the system actually works and how the data is saved, exchanged, and how this data or information are properly, let's say, organized, stored, and how you can use it in the further stages of, let's say, construction, in the old stages of construction, and how these information can be properly organized in order to each different participants can just extract the part or the portion of the information which is valuable for them in that time of, let's say, specific time of the project where these information should be analyzed and, let's say, exchanged with the other participants as well. So the first part is, let's say, data verification, which is one of the most important, let's say, processes related to quality assurance, and this applies to the all project stages. In this case, BIM checks can be, let's say, performed based on customized or standardized IDS analysis, and also we prefer IDS based on the Excel spreadsheets, because IDS structures and organized in a simple way is something that, as I mentioned before, anyone can easily understand and change. So it's really simple and accessible to everyone, and the system will go through these multiple, let's say, IDS facets and find issues. And all elements with that which are not in compliance with the information delivery specification will be organized into groups by missing, let's say, missing properties or inaccurate properties, also missing or inaccurate attributes, classification, materials, and so on. And then all these results can be sent directly through BCF issues to other participants, or these could be exported to Power BI reports, for example, which is one, as I've said previously, one of the most important processes in the coordination. So the first video, which I'm currently presenting, is more informative just to understand how all these information are preserved in form of, let's say, data container in a way, and where all sources of information are stored. So the entire process starts with the publishing all results of the analysis which are created within the software used for BIM checks or for other types of analysis. These results can be published to the cloud-based common data environment. And during this process, user can even specify and define which portion or which part of, let's say, IFC file information they want to send to the client, to the cloud. These could be originally used IFC files or segregated into smaller pieces in case that you don't want to share or expose entire projects to everyone. So in each revision of this published, let's say, information, we have the history saved. So you can always go back to save, to explore the previous results and the previous, let's say, information which were stored, all is stored on the cloud. And also project attributes and properties are also saved without any data loss. On the other hand, all results of performed analysis with additional information such as coloring schemas, clash results, property check results, cost and schedule information are also saved and exported into external sources of information in form of JSON or Excel spreadsheets as well. So these results are linked to previously exported IFC data, and using customizable Power BI reports in this case, could present different type of information to different project participants in a really meaningful manner. And from personal experience, I would say that these results performed using these types of analysis are organized into really clear and visually, let's say, stunning type of information, which are easy to understand to different types of participants. So in this way, we could introduce, let's say, BIM checks to design team in one way, but we can also present all these types of analysis and results of BIM checks to, for example, clients in a little bit different way. So everyone can just take the information which are relevant for them and which are the main, let's say, focus of that participants of the project who are analyzing these results. And by doing so, we can evaluate and, let's say, in this case, organize inconsistencies. In this case, you may see in a video, all these results can be differently organized. We can analyze different types, IFC entities, different classifications of the elements, and all the data can be stored, as I've said previously, and accessible anytime. And when the project is updated, this is one of the, let's say, best benefits of this kind of approach. When the project is updated, the system will automatically update results. And just by using the export button, we can, again, export all these results again. Everything is stored on cloud, and we have another revision of these results. And these results can be, as I said, again, visualized and analyzed for the next, let's say, stage of the project. So another important type of BIM analysis, especially in the early stages of the project, is coordination and collaboration between different trades, and also performing clash detection is relatively valuable in every project. And this process, in briefly explain the automation, which starts with the federated BIM project, and then it's fed with the predefined or standardized templates for creating clash detection groups on one hand, and on the other hand, the clash detection configuration templates, which are mixed together, and the system will automatically find issues between different trades, different groups, and all results, as I said previously, can be instantly saved, exported to different types of reports. You may see that these reports could be different type, PDF files, Excel spreadsheets, HTML files through API to connect with different systems, and also Power BI reports directly. So again, everything is stored on cloud. All this information, as I said previously, when the Power BI report is open from this system, we can analyze results. And again, based on different data subsets which can be exported, different results can be saved on cloud and also presented to different participants of the project. For example, clash results between coordinators and between design teams are presented differently, and also for subcontractors, for example, we can include cost and schedule data. So a client or the project owner can see clash detection analysis combined with the cost information. And for example, design team can just see clash detection collisions between different trades without any other information which are not related or important for them. So they can just analyze information related to, let's say, in this case, different buildings, different trades, different types of or priorities of these clashes, and also some common information such as building stories or different subcontractors. So every subcontractor can see, or any, let's say, trade can see the clashes between just their own different types of installation, or multiple, let's say, trades or multiple subcontractors can see where they have collisions with the installations between each other. So all these found issues can be relatively easy identified and also organized and resolved in order to avoid any possible issues during the construction itself. And of course, if the clash analyses are performed progressively during several months of this kind of progressive clash testing and design collaboration, so we can also export this kind of data, which contains all these progressively saved information during multiple previous months of coordination process. These results can also be exported into different type of results, into, for example, way of combined information into portfolio manager. And this is something that I will show you a little bit later. But currently, these are just different types of views which anyone who is actually exploring the process of clash detection can access very easily. And this is something that I tried to mention previously. All these results, which are done in a past period, can be exported into this kind of, again, cloud-based platform, which saves all this data, not just, for example, from one project or multiple versions of one project, but also from multiple types of the project. So you can analyze different types of collision, or not just collision. We here talk about clash detection, but also you can analyze in this manner cost information. You can analyze the quantity information, multiple buildings, multiple types of the project, and analyze what is the cost of this type of the project again against the other type of the project in a multiple, let's say, different countries. So you can analyze, okay, this is a cost or number of the clashes which I obtained or analyzed in one country, and this is the number of the clashes in a similar building, similar size of the building in the other country. So this kind of information is really valuable for the project owners as well. So even if the model is missing some required properties or values of these properties, or if some of these things are not accurate, we can use another feature or another process to automate the enrichment or data enrichment of the model itself. And again, based on using customizable Excel spreadsheets, for example, because these are, again, open BIM standard, we can add information or properties to BIM elements. And all properties, no matter if these are original one or added, can also be saved within the IFC schema or separately as a separate chunks of the information and exported to Power BI. This allows us to do different types of, let's say, various Power BI, again, templates for different purposes. And also, I just want to mention that if we previously, for example, used IDS for verification of the quality of the BIM model, the similar templates for IDS could be used for data enrichment. So based on, for example, IFC entities or attributes of some of the elements, we can do the similar thing to enrich existing elements based on these predefined attributes. From the, let's say, open BIM uses, using our application, we can export different types of information. And as I've said previously, it's really important to decide which information we want to share, in which point we want to share all information to respective participants on the project. And in this case, we, for example, are just sharing or analyzing area information. So in this case, IFC spaces information are actually sent to the cloud, and using, in this case, Power BI template, which is done for this specific purpose of the project, we can analyze areas of the project. And this could be really useful in the initial stages when we're deciding about the areas, different types of the areas of the project, which types of the area of the project these should be. And based on results of these types of analysis, we could discuss when and what on the project should be changed before the construction or the next stage of the project starts. For example, from the concept design to the real, let's say, issue for construction stages. And this is just one of the examples how we can use this data and how this data is actually saved. So in one place of this template, we can see quantities and different types of the different areas, but on the viewer, we can see different types of color schema. So we can always see, for example, area, volume, number of the users who can populate specific area, or we can see, for example, finishing types of floors, walls, ceilings. And at the same time, we can analyze how these areas are differently, let's say, structured. If we see, for example, in this case, different departments, different types of the areas, or if we see, for example, different uses of this area. So we can differently color code all these information based on something that we are currently want to explore. In this case, we see, for example, different departments, multiple types of the projects, and each of these, in this case, 8 different types of rooms. Each of these has different, let's say, types of rooms itself. We have areas, rooms, zones, whatever, and all these can be differently color-coded, differently organized into different, let's say, buildings, stories, sizes of these rooms, anything. Also, we can use and include information about the usage of electricity per each room, or, for example, lighting analysis as well. So all this information can be stored, exported, and again, depends on the user, which information they want to use and in which purpose they want to analyze this information. And this is just another example, different type of the project. This was previously two high-rise buildings, but in this case, we have a power station building. And power station building have a totally different types of these areas. So these different types of the areas can be organized in a different way. We can analyze different information. We now don't really need to understand what are different types of the rooms, which can be used to sell different types of, let's say, apartments. In this case, we are more interested in the, let's say, power consumption. So in this case, we can analyze power consumption information. We can analyze all different aspects of information which are stored and available based on something that we want to analyze at specific moment. So another example of how we can export and again analyze different type of information in a timely manner is quantity takeoff. So previously we analyzed, for example, just simple spaces, but in this case we decided to just share quantity information. So we have 3D IFC information related to geometry of the elements, related to the quantification or quantity takeoff of these the same elements that we currently see. So we decided not to share, for example, cost data, not to share data related to clash information, property checks, and so on. In this case, the template that I'm presenting now is used for quantity takeoffs. And someone who is actually want to do some kind of tendering packages can use these quantity takeoffs to organize data, organize packages that they want to create or to share with other participants on the project. And this is really interesting because it's interactive and it's really easily accessible. So anyone who has a relevantly, let's say, simple understanding how entire, let's say, system works, where the information are saved, and what is behind entire, let's say, IFC standards, can just simply analyze this kind of template and understand, okay, this is where my quantities are, these are the accurate quantities, and for example, analyze these quantities based on subcontractor, based on different types of the elements, based on different building stories, different trades. For example, we can simply analyze piping system, where and what kind of piping systems we have in each level of the building, and then we can analyze each item, quantity item of each of these selected or visually presented items, and we can see exactly what is the quantity, what type of these information are, and also in this case, we can also analyze, for example, or color code these elements based on, for example, a classification system, in this case, uniformat classification, or we can do any kind of color coding based on any classification system. So everything is totally open to everyone, and based on the project itself. So any classification that you are using, all this information are linked to 3D elements, and then we can analyze and export this information and separately use different types of information for the specific, let's say, use case that we are currently using or working with. In this case, for example, I'm just presenting some interior partition walls on multiple stories. And we can really easily see where and what type of these partition walls are. And again, we can very easily understand what is the quantity, what are exactly types of these wall. And again, this could be done for any type of item, quantity item, or any, let's say, building part. So foundations, now we can just analyze foundations based on specific subcontractor, different type of structural works, core walls. Really simply, we can visualize and understand where and what type of the works are. And then these kinds of information, again, are saved. When we update the project, information are updated. So we can just update the entire Power BI template to the online. And then when we access to the online platform, we can see the previous results, history, and we can see the updated information as well. And we can see what are the changes, and we can have the relevant information just in time. And again, just for the last, let's say, example related to the quantity analysis, or the part of the session which is related to analyzing this, let's say, more or less simple information such as quantity takeoff properties, clash detection information, more or less all information which can be automatically obtained from the information directly extracted from the geometry or IFC files itself. And in this case, I'm just presenting how the same or similar template for quantity takeoff can be applied for infrastructure project. In this case, it's a railway project, and we can analyze quantities based on different types of works, for example, for railway, for a road, or for the bridge above the rail, and also based on the subcontractor. So if we have a multiple subcontractors, or again, different types of work. This is, for example, excavation, but we can see different types of work, for example, concrete works, or setting up the electrical railway roads, or something like that. So anything can be easily accessed by anyone. It's quite simple type of templates containing relevant information. And this is, again, related to the information which can be almost automatically extracted from the IFC files, and maybe additionally enriched if it's needed. But now I want to hand over again to my colleague to explain you a little bit more advanced processes when we can extract and analyze information, not just automatically extracted from the B model itself, but something that we can do additionally by adding cost information, schedule information, and so on.
Thank you, Mileta. So if we talk about cost management in our system, in our platform, we have two general approaches. So the first one is a more straightforward one, where you have your cost classification system, whatever type and standardization it is, or if it's completely customized for a company, and you basically can import that cost classification in the form of machine-readable Excel spreadsheet, define what we call element queries, or the filters, which will allow you the link between cost items, cost item definitions and the models, and quantity formula, which will define the way you're quantifying your data for that specific cost item. And then assign it, of course, link it to the model elements. And with every new change, with every new update of the model, the process of updating the cost is basically completely automated when you just update the existing cost classification, of course. And of course, that cost classification then could be reused on the next project, and you're just, using the knowledge that you have acquired on one project, enriching it, updating it, and just, moving and making that knowledge base bigger. Another one is where you have ability to use predefined templates to auto-generate cost classification. So where you don't have the cost classification with the defined rules that are linking the model elements, where you are not having the quantity formulas predefined for every cost item, but you have templates which you load from your knowledge base that are prepared, and that automatically, based on these templates, based on the coding system that you have, based on the rules, quantity calculation rules, is defining the cost classification for every new project. Both of these processes are highly automated and allow you actually to free up the resources needed. In first place, engineering hours, the resources needed for the 5D phase of the project, so that the experts could focus on the creative work. Experts could focus on creating reliable data, accurate data that is up to date with every new project update, and not losing their time on calculating something in a manual way, which even when they get the good information, too much resources are spent on that specific calculation, and that information is already outdated. As a result of this process, we can export such an Power BI dashboards, I would say, interactive dashboards, where other participants could approach this database, but not only see, as a single database or some PDF document where I have to go through the rows and to find exactly what is the part of the cost classification that is important for them or that is relevant to them. They could very easily sort the data, they could reorganize the data, they could focus on the part that is relevant for them in that moment. And that's the major power of this approach, where all that data is simply very easily readable and manageable, so that you have ability, maybe for one subcontractor, it is important to manage resources, or for the other one, he's managing just the unit prices and things like that. So you can customize these reports in unlimited number of ways, and you can actually see the relevant information in the relevant moment, and you can focus, you can just navigate very easily to the part of this cost database, of this budget that is important to you. This is just again very, very simple example of the same dashboard, of the same type of information, just on the completely different type of the project, on the infrastructure, where you don't have a classification system, standardized classification systems in terms of IFC entities and all the relevant classification categories, but you can still access this database, and you can actually navigate to the custom properties that are defining your spatial structure, your work groups structure, and you can easily navigate and see the part of the project that is relevant for you, if it's a subcontractor, if it's a work type, if it's some spatial category, so you can easily navigate and see what is actually relevant to you. And of course, it gives you opportunity to have verifiable data in the first place. That means when you click to certain information that tells you how much something cost and what is the quantity of certain amount of work, you can see exactly what was meant by the person who created that data for the BIM manager, or in this case, quantity surveyor, what he was counting in when he calculated that data. And that's the highest quality of this approach, where you don't just look at the numbers and you have to trust it. And in most cases, people just don't trust it. They just, raise the contingency, and that's why the prices just go higher and the risks are higher, and then, everybody loses. So in this case, data is transparent, data is traceable. You can trace the source of the data. So whatever changes in the source, changes in the data as well. And you can make sure that what you're seeing is what actually was calculated. So that's probably the main advantage of such approach. Of course, I mean, the platform itself also allows you to create animations in this sort of reports, which again gives you opportunity to just combine different domains and to see, when not just even in 5D data, not just the 5D data and the cost, but also the time dimension of the cost. So you can see, let's say, when you're going to have the certain types of works, when you're going to get certain subcontractors, and so on. When we talk about 4D, or what we like to say 4D and 5D construction planning, again, this is probably the most complex part of the project management workflow, I would say. And it requires a lot of work, a lot of engineering hours to develop proper schedules, and then to link those schedules with the resources and with the model elements. So this is where we probably press really hard when it comes to automation, and where we probably achieve the best results, I would say. Where we were able to automate the process of the sole generating of the construction schedule, where we just abandon the workflow where you just go and create one task at a time, one relationship at a time, and where we allow the planner to actually create the logic of the schedule, to focus on the logic, on the work sequence, of the spatial structure of the project, on the optimization of the schedule, and just get rid of the simple process of creating and repeating the same schedule tasks and schedule relationships, and just wasting hours on some manual labor. So I'm going to try to briefly explain you what is the logic behind this system. It is, so we basically just analyze how the planning process works in general, and it works in a two main processes, I would say. You could just, it simply goes to two main processes. One is spatial project organization, or spatial works distribution, where you distribute your works on your project by spatial categories. That means if you have two buildings on the project, you're going to first distribute it to the building 1 and building 2 and define the relationship between these two zones. Then you have 5 floors on every building. You're going to create, to just put it simply, you're going to create subtasks in those parent tasks for the buildings, create relationships between them, and so on. And another part is methodology, or work sequence definitions, which is basically just the order of work execution. And what is the problem in a traditional approach to planning is that, like, a simple thing that is intuitive to every engineer, like, let's say, first we're going to execute vertical support structures, and then the horizontal one. You have to go in the traditional process and repeat that same work sequence on every floor, on every zone, on every building in one simple project. So you're just repeating the thing that is pretty intuitive and that was already defined in the first installment of that schedule. So in our approach, what we're doing, we're just organizing, I would say, levels of schedule structure. That means that you're organizing levels of spatial organization, you're organizing the levels of work sequence definition for a complete project in one central place. And then the computer algorithm combines all of these logics together and create the schedule itself. So just to simplify it, you specify the order of executing the buildings, then you specify the order of executing the activities, the order of executing sub-activities, floors, and subzones, let's say. And the algorithm just combines all of these logics and creates the schedule itself. That means creates the tasks and the relationships based on the logic that the human planner actually created and that inputted. Why is this important? It is important not only that it cut the time for the planning itself, but because the whole process is pretty scalable. That means that the effort that you have to use for, a 2-building project is more or less pretty much equal to the much larger project of 20 buildings, because you're just defining the logic of schedule organization. So let's say those are the two projects with the same technology of execution. The methodology of work sequence is more or less the same, so you can reuse the knowledge from the previous project. You're going to just modify the spatial structure of the project, which is more complex in this case, and you're going to get a schedule that is like 15 times bigger, but with more or less the same effort used in terms of engineering hours spent to actually get the good results. And why is this important? Because this gives you first opportunity to create accurate schedules, detailed schedules, and more detailed schedule is in general more accurate and more realistic, and it will just give you enough time to focus on what is relevant, what is important, to focus on optimization of the schedule, to focus on the resource leveling, to focus on all those things that are just you just don't have enough resources to do if you go with the detailed scheduling in traditional way. Also, this complete methodology is not limited to this explained example of high-rise buildings. We also use it, in a very good way in the infrastructure as well, where just the spatial logic is a little bit different, where you don't have horizontal and vertical distribution of works because those are linear projects, but you just have, linear projects work distribution in terms of changes and just axis of execution of these linear projects, but you can just reuse the methodology in the same way as you did with the buildings. What this means, if I build a tunnel or if I build 5 tunnels, I'm going to just create the methodology for one of these tunnels, and I'm going to just use it on all 5 of these, because probably if the technology, of course, is the same, because the work sequence is the same, and I can just rely upon the system. And this is probably this is a good example that I want to show. Oh, sorry, just to see if it started. No, the video is. No. It seems like we have a problem. Yeah. We can just put that in on that side. Mm-hmm. Can you just, yeah. Okay, thanks. So, okay, today I wanted to show this this video, which is specific, but shows you what is a power of this approach of managing the data, I would say. So this is a completely linear schedule, linear project. So it's an infrastructure project, a railway project in Germany. And the point is that, let's say, visualizing the data for the schedule is not, it doesn't have the same requirements as with the high-rise building. So the Gantt chart is not that useful. The line of balance view, again, is not giving you the complete accurate picture of the project. This is where most of the planners require what we call linear schedule data. And by managing the data in such way that you can just export everything from BIM in an open format, and you can, I would say, play around with all the data and reorganize it the way you want, we can just simply in the Power BI achieve what we need. We can just recreate the linear schedule data and to actually see the project data. So it's the same project data as with any other project, but we can reorganize it in a way to see it the way we want to see it. So in this case, we want to see a linear diagram, because that diagram gives us better perspective how this project is going to be executed. Of course, again, this is an infrastructure project, so all the locational and functional properties are more or less project unique, customized. So also with this approach, we have ability to export all of these project-specific properties and to use them to sort and subdivide the data in the project, or in this case, progress data, schedule data. And of course, we also have ability to visualize the schedule itself. So to visualize animation and to combine that visualized animation with the linear schedule data that is relevant for this specific workflow and for this specific project. And so this is, I would say, when we go beyond the software, beyond the platform. So you don't need to have user interface in the platform. If you want to see something that is specific for your type of the project, you can just export the data, you can organize the data you want, and you can visualize it the way you want. In the same way, you, as in previous cases, you have traceability. So whenever you select the part of this line graph, you can see to which element it refers to. So data is reliable and data source is transparent, as it is in some user interface in some platforms. So this is probably the best way of using this way of managing the data of the BIM project and exporting it, because it gives you freedom to customize what you have in your BIM model, and you're not limited with the user interface. You're not limited with the platform itself. You can just organize it the way you need it. Another process that is also important in our approach, in our ecosystem, more or less, is BIM progress monitoring process, where we again try to automate the process of BIM progress monitoring, and to avoid, I would say, again, unreliable data when somebody is sitting on the construction site and just assessing by itself if this is 20-30% complete. In our approach, it is a bit different, because we have a BIM model, we have integrated 5D data, so resources, cost. We have integrated 6D. We have a pretty detailed schedule. We have opportunity to easily create or to define what we call look ahead plans. That means that we can, in the form of BCF format, share with the people on site exactly which elements are planned to be executed in which period of time. They could again see through these reports a link between those elements and the needed resources to execute them. So they could plan their process in a better way, and in the same way they could return the information throughout system, again using OpenBCF format, where they could select exactly which elements were completed. They could specify exactly which activities on those elements were completed, and then when we receive that on our side on expert platform, we can just very easily populate that progress in the expert platform, in Bexel Manager in this case. And again, we have ability to export that data in the form of Power BI, where again that data could be very easily managed and reorganized in a way that we saw in a previous case. So in this case, it's an earned value analysis. So you can visualize through the color coding, let's say in this case, subcontractor. So you can see exactly which part of the project is dedicated to which subcontractor. So you can easily navigate and to see who is working and who is responsible for each part of the project. They can just easily see what is a focus of their work. They could see what is performance of them exactly. So they could just navigate, drill through the data very easily, and to see exactly, where we are, what is the planned value, what is earned value, what is actual cost. We can just see which parts of the projects are going great, which parts of the projects are going bad. We can visualize, in this case, schedule performance index, so we can see exactly in which month we were performing good when it comes to schedule-wise, in which months we just had the bad performance. Then we can discuss why this was the case. But the point is that the data is, again, very transparent. Data is, again, very easy to understand for all the participants of the project, because, again, there is no platform, I would say, problem where you need to just use all the same platform in order to see the data. You have free access and you can reorganize the data you want. So it's completely clear idea where you are. So you can see, now we started with in red. That means that we had pretty low schedule performance index at the beginning. We improved a little bit in the middle part. Then when we reached the viaduct, in this case, it was go to green. So it's I would say natural progress of this project. You would say, okay, it's understandable that at the beginning we were not just as productive as we expected, but then we improved throughout the time. So you can actually, and you can see where are the weak spots and who is providing you with the relevant data, and who just doesn't have enough resources on the site, or whatever could be a problem in this case, and whatever could be a reason for good or bad results on the projects. And again, as in previous cases, traceability. you can just very easily navigate and see it. Time-wise, I want to see what was performance in that month or that period, that week or that period of time. I want to see what is performance when it comes to the subcontractor. I want to see by groups of works what are the key project indicators. And I have a big picture, but I also have very easily a particular picture of specific domain of my project, and I can very easily assess how my project actually works. So again, just to see. Okay, so besides all of this, so this was just the earned value analysis. We also have ability to automatically export monthly certificates. That means that when you populate the progress that comes from construction site, you have ability to visualize the work that was executed in certain period of time. And again, you have overall picture where you have very clear idea, what is the total cost, what is cumulative cost up to that specific moment, what is the executed in certification period of time, what is balance to finish, and so on. So you have, something that is standardized way of dealing with the monthly certificates. But what is different from a standard approach where you have some Excel spreadsheet or where you have some PDF files and reports is that, first of all, again, the data is traceable. So you can specify every cost item, every month, every subcontractor, and see exactly what was executed in which period of time. And you can verify it on construction site. So the 3D model needs to reflect the data on the actual data on the construction site. And another thing is that you can very easily sort the data, and you can very easily navigate to the part of the data that is relevant to you. Also, you can, throughout this system, again, visualize the cost performance index, schedule performance index, all of these key parameters that could be very relevant for you and for your decision making throughout the progress execution. So you can, simply go select, like in this case, certain subcontractor and just visualize its performance cost-wise or schedule-wise throughout the time. You can see, and just you can compare their claims with the performance on the site and to see if this is approved or not approved, and you have the complete history of what is happening on the project in this way and in this case. So, yeah, thanks. Okay, and just as we said, parallel to this process of chain of, I would say, events of the workflows that goes from the start to the end of project life cycle, you have two processes. One is reporting that we covered, in these different domains in particular, but what you also have all the time is maintaining and updating of the federated BIM model. And this process is also something that requires time, especially on the big projects. So what we're also working on is automated model update, or command center. So at this moment, it's in its infancy in the beginning. So we're first dealing with the automated BIM model for the use cases where you have a huge project with, I don't know, thousands of different IFC models from different authoring tools that have to be regularly updated. And due to limitations of the hardware equipment, that just takes an incredible amount of time. At the moment, we have a workflow that could just automate this process. So to feed this data in a more automated way, and again to release the resources in first place, human resources for more creative work and for the analytics. Now we're going to switch to your slides. For the future.
Yeah, so just before we, let's say, wrap up this topic, I want to just inform you or explain a little bit how we are dealing with the current IFC schema and what is available currently, how we're dealing with it, and also maybe if we have some time to, let's say, introduce you with some current issues that's supposed to be, let's say, discussed a little bit let's say, further during the next stage of development of IFC and maybe IFC 5 and so on. So this is existing IFC schema, and you may see plenty of information for cost and scheduling. And these are information which are already available. And it's really great that we have this kind of information that we came so far. But hopefully it's just going to be a basis for the future development where we can have more, let's say, semantic related to this information or behind this information, which will be possible in the future, because currently these are more or less results of cost and schedule information that we embed into let's say 3D elements. But let's say another one which is related to the cost, it's similar situation. We have already defined and developed model view definition up to a certain level, but hopefully it's going to be improved, especially when it let's say when it's possible to clearly define all possible use cases. For example, currently we're missing a definition for cost classification, and it's really important because sometimes we need the multiple cost classification in a project, and we have multiple cost classification in the world we are using, or even the same company using different cost classification for different projects depending on the client. So it's really important to have this kind of information in a way available and linked to information originally, let's say, used IFC information. So for more aspects related to cost and scheduling, we are this is the slide. So we already included the future, we are as a company included in the future development of IFC as well. And I'm just going to briefly mention some of the ongoing topics. For example, task element sort order, which currently is limited available, and at the moment we can use, for example, IFC alignment direction for showing how the elements will be executed during the scheduling timeline. But if the model is updated in another tool, for example, then this information is going to be lost. So the user will need to do the same, let's say, linkage or explaining how the order is going to be executed when the model is updated. Another thing is, for example, something that we call beam queries, or also these beam queries could be related to cost and schedule as well, because if the model is updated, the schedule is again in a way lost, because all new elements which didn't exist in the previous let's say iteration of the project will need to be additionally added to respective tasks, and then we need to include again cost information. It's not updated automatically, so we need some kind of beam queries or relations which will automatically in a way refer 3D elements and some kind of information about cost and tasks as well. Also the same goes to the quantity formulas. When we update the model, we would like to automatically calculate the quantities and cost estimation of all newly created elements. So we have additional proposals related to cost and schedule as well, related to some more advanced functionality, such as, for example, progress entry specification, since the current progress specification is relatively limited again. And the next one is related to task calendar and work life, for example, calculation between pre-successor and successor tasks. So it depends how we're going to calculate it, and it would be good to be included as well. Also, we have more minor proposals related to, for example, relation specification between task and cost items and between baseline schedule as well. So that would allow us to produce earned value analysis as we presented previously in the Power BI reports. Also, the same goes for location-based scheduling. So we could have some kind of zone sequential relations and specification that allows us relation between tasks and zones of the elements in the BIM project. And we do have a few examples that explain previous issues with the current MVDs. For example, how the cost items from cost classification can be interpreted or used in the same, let's say, cost estimation or bill of quantity, but in a different structure. So it's also common, let's say, situation in a real project. So this is, again, another issue that we have to deal with. Our bill of queue, for example, can differently be structured than original classification. If we have multiple building zones or multiple buildings, we have one project, one classification, but we have to, or we want to organize these cost estimates related to buildings, or for example, related to subcontractors for tendering packages. Okay. So another thing is, again, ability to connect cost items with tasks. This currently is possible in MVD, but it's not used at the moment in a way that we would like, for example, and also it's not much for related to project management tools where we have an entire, let's say, concept in our application developed. We believe that accurate project management and the processes related to project management are really important because that allows us to track activities, track resources, quantities, and so on. This is an example how the, again, end results are created using available or current cost and schedule values, but we need some kind of logic behind that semantic which is currently missing. And when the model is updated, we would like to have all these items automatically updated, so we don't need to redo the process every time that we update the project itself, or every time when we update schedule or cost information separately. So 15 minutes. Yeah, so we achieved, for example, in our application, what we are proposing in and this is just a possibility, for example, for rules or queries related to cost items that could be used to collect respective 3D elements and link 3D elements with the respective cost classification items or tasks information. And this is really good use. And also quantity formula, which is used to calculate quantity and price related to 3D elements. And this one just shows the logic behind the cost items, which we used originally. We have cost items related to 3D elements and bill of quantity, and after the updates, the system automatically recognizes the updated elements based on these previously mentioned queries and quantity formulas, and the system automatically updates all this information, and we have it instantly. So we don't have to repeat the process from scratch again. And this one here just examples this coloring schemas, which allows us different types of coloring based on a different structure or a different property used in the schedule in this case. But as I said, these coloring schemas can be really useful when it comes to exporting to Power BI. So we can use any kind of information, any property to color code the elements, and this would be also really important if we have it within the schema defined. And this is just another concept that we would like to discuss more in the future. And as you may see, it's more about possibilities that these things could enable, especially if the model is updated, as we mentioned several times today. So this is, I believe, the final slides for the presentation. In the future discussion, we would like to enable schedule export even without 3D elements, and by, for example, enabling external references between cost and schedule items and 3D elements, preserving some kind of link and logic, we could easily exchange relatively, for example, small files with cost and schedule data and just use it on an updated or changed project that contains geometry, for example, with preserved information and relations to them. So everything could be instantly updated and would be automatically ready to be used. So thank you very much, everyone. I hope that this topic was interesting and we can have some questions.
About 10 minutes left for questions. Do we have any in the room? We've got some online as well. So you can read these online, and then basically it's these from the book.
If you want to take one of these.
Go ahead and read that one.
Should we read it first?
Yeah. Mm-hmm. Okay, first, the BOQ module is basically following SMM4 standard, English quantity standard. Well, no, BOQ module is completely open for any. It is not hard coded in any way, so it's open for any sort of.
Okay, so, okay, number 2, for what was it? Testing.
Okay.
I've got this one over. For construction resource management, which module could help us to monitor the site progress, especially compared with major tasks in the working program critical path? Say the manpower management in the major task when the manpower is not enough and the estimated time of delay under the construction manager inputs on the estimated manpower.
Okay, well, that could be actually managed in the schedule part of the scheduling module of our software, where the schedule is all the tasks are connected to the resources data, and you have resources charts where you can actually see the level of resources needed for every task, for every period. And again, it could be drilled down as we saw it in the examples, you know, to the lowest category of this domain. So yeah, it could be managed in the schedule domain.
And also there are available already some tools based on which could automatically extend or change duration of activities based on resources available or based on the, let's say, daily productivity.
Yeah, so related to that, any weather impact? Any weather impact in relationship to the working program, say the estimated days of delay under, you know, a weather impact, so storms, blizzards, you know, something that does that.
Everything comes back to the progress inputs. So all these things, if you have some kind of delays related to any kind of outside issues, you can add this into progress information, and then the system will automatically recalculate delays or window delays based on different types of information you edit when you edit progress data. Okay. So it could be intentional delay, or this could be some kind of based on the outside, let's say.
And his last question is, any AI analysis function for cost management, time management, energy management, or can we integrate third-party software for that?
At the moment, no. We're still not including. Yeah, maybe the
Hold on,
could
just a
give us some update on this.
Actually, API is open, so you can always integrate it with third-party applications.
Testing 1, 2, 3.
Thank you, Jeff. So this is more related to the IT stuff, so I will answer the question. So we did a lot of things in terms of AI, but and the system can literally do whatever you want. So you can say, okay, 5 million is the monthly cap, and you cannot perform works which are more than 5 million. Or you can say, of course, limit resources or any other thing, or optimize even automatically net present value, so to extend the cost of the last phase of the project. But what we also realized that we call it controllable or manageable AI, because, you know, just to leave everything to the system without your control, where you can trace how this is generated, is not always good, because then, let's say someone die on site and you cannot say, oh, but the AI algorithm created that work sequence of order. So it must be strongly manageable thing. And what we have to say also, sometimes the AI algorithm does not follow the common logic of the workers. And he will say, okay, today you will work here and tomorrow with another crew, totally different location. And although in theory it looks ideal, in reality, it's not the efficient and common way. So that's what we call controllable AI. And on other side, what we have several research, EU-funded research projects where we are involved. We now analyze the lot of schedules of large contractors and give suggestions to them how to optimize the processes. So this is ongoing. There are 2 ongoing research projects where we are. So I will say controllable AI is something we honestly believe is the future.
Any other questions from the audience?
I have one clarification is required for the scheduling part. Is this, do you have a full-fledged built-in scheduling capability like Primavera or so we don't need any third-party software for that?
No.
Yeah, it's fully BIM-based scheduling engine, which I believe Aleksandar explained already. It's based on the information available in the 3D model related to zones, and then you can specify your methodology or work sequence logic between your work groups, and then the system will combine these two and create tasks with all links between respective tasks. And everything is again connected with the cost information. So you have automatically full 5D schedule.
If I may just so of course, full time engine, and maybe there are slight small differences between Primavera and Microsoft Project time engines, and we try to support both. So when you import the data, you receive the same result. But what Mileta is referring to is that we strongly believe that 95%, and actually that is achieved on hundreds and thousands of the project, 95% of the schedule could be automatically generated. And then you can fine tune it in Bexel Manager. Of course, there is also a traditional workflow when you just import the tasks from Primavera on Microsoft Project, and then the system automatically do the matching. But the problem is that then the data is, you need to spend months to manually create a schedule, and you will immediately notice that a lot of tasks are missing or wrong sequence and so on. So instead of doing that, it's much better to majority of the things do automatically as it was presented here, and then just do a fine tuning. And Bexel is as I mentioned, support both time engines, so you can decide whether you will use. One is just envisioning that calendars are are related to the successor task, and another is to the predecessor. But more or less, you can fine tune this.
Okay, I guess there's about 4 minutes left. Any other questions?
Hi. Two questions. One regarding how you use the Power BI. So you just to understand the logic, you do all the configuration on the Bexel, and then to show the client or to show other stakeholders, you use Power BI. That it?
Yes, we actually automatically export the dashboards, and we export the data in the form of JSON files in most cases and open Excel files, and then that data is automatically refreshed or pulled to the predefined, in this case, predefined dashboard, but that dashboard you can just use and customize the way you want. So we just give you some standardized dashboard, or I mean, a range of dashboards that we have, but you can further customize it if you have the knowledge of Power BI, which is pretty simple. And then you can, I would say, play around with the data. So you can reorganize, change the charts, change the domains. So everything is completely open in that matter. So you can reinterpret the data the way you want. You're not limited with the user interface of the platform.
Then in Power BI, it's not possible to send information back.
If I may just, so maybe one thing is, first step is that you decide, we call it fit for purpose IFC subsets of entire set of IFC files. So first, the system, Bexel generates a lot of customized small IFC files, which are published for a certain analysis. So you don't want to see all tunnels on your project. Maybe you just want to analyze your only one tunnel. Then Bexel generates IFC files based on any classification you would like to use, and this is in Bexel Viewer. The next thing is, if you want to communicate, you use our standard application. It's called Bexel CD, and there you can raise the questions or comments and send it. And this is, unfortunately, in this case, was just that small part, which is called Bexel Viewer. So the communication cannot be done through Power BI because you know, it's endpoint, so it's just for analytics. But in that small screen, you can zoom it and communicate and set back the information. So that's the way how you communicate.
Thank you.
All right, well, I'd like to thank everyone for coming. That wraps up this session. Oh, wait. One more, okay, one more, yeah.
The last, I hope. So I have seen in the first or second slide that there are a list of benefits and improvements from Bexel tools, and there is indicated also something about the mitigation risk. But there is a dedicated tool or some action dedicated on these points, or it's only a theoretical mitigation? I don't know if it's clear.
Maybe I don't know. Just the thing is, you're referring, of course, that's very important, and delay analysis, and for example, window delay, and so on. So this is, we would be happy if what is presented here could be achieved in IFC.
No. Yes, it's out of the scope.
But in the future, definitely, that's one of the crucial things. So to have fully integrated risk management and claim management and so on. So that's the future, definitely.
Okay, thank you.
All right, thank you, everyone. And please join us downstairs for lunch, just like yesterday. And then the next sessions will reconvene, I believe, at 1:30. All right, thank you.